There was a profound moment when what was once called the Andromeda Nebula suddenly became recognized as the Andromeda Galaxy. For many years, our knowledge about Andromeda was confined to observations made from Earth. But with the advent of advanced technology, and especially the launch of the James Webb Space Telescope, our understanding has expanded immensely. Recently, the James Webb Space Telescope detected unusual and alarming signals coming from the Andromeda Galaxy. These signals have caused a significant stir within the scientific community, leaving astronomers both intrigued and puzzled. Their exact meaning of these signals remains uncertain, but they have sparked deep curiosity and concern among experts. Just moments ago, the James Webb Telescope halted its operations after picking up these alarming signals from Andromeda. In the early days, before we could peer deeply into space, astronomers believed the Milky Way was essentially the entire universe. This limited view was mainly due to the technological constraints that prevented us from observing distant galaxies and individual stars beyond our own. The discovery of the Andromeda Galaxy was a turning point, revealing that the universe extends far beyond the Milky Way and beyond what we could have imagined. The story begins in the 17th century, when Galileo Galilei, using his pioneering telescopes, revealed that the Milky Way was composed of countless stars. This challenged the old belief that the Milky Way was unique and singular in the cosmos. The real breakthrough came in the 1920s with Edwin Hubble's observations through the Hooker telescope. He identified celestial objects outside our galaxy that were entire galaxies themselves, one of which was the Andromeda Galaxy, also known as M31. Although this was the first telescope-based observation of Andromeda, it had actually been noted centuries earlier by the Persian astronomer Abdal Rahman al-Sufi around the 10th century. Thanks to 20th century technological advancements, astronomers could finally explore the true nature of Andromeda, discovering it was a vast galaxy similar to our Milky Way. Andromeda is a massive cosmic neighbor located roughly 2.5 million light-years away. Since its discovery, the methods for studying it have dramatically improved. We transitioned from relying solely on ground-based telescopes to powerful space observatories like the Hubble and now the James Webb Space Telescope. Each technological leap has unveiled more secrets about Andromeda's composition and structure, making it a key reference point for understanding how galaxies form and evolve. Studying the relationship between Andromeda and the Milky Way is crucial because these two galaxies are destined to collide in about 4 billion years, a cosmic event of tremendous significance. Despite ongoing research, the James Webb Telescope's recent detection of an unusual signal from Andromeda has puzzled scientists globally. This signal, originating from the galaxy's core, appears very different from previous observations. It suggests major dynamic processes may be occurring, potentially linked to Andromeda's supermassive black hole or other phenomena that have not been discovered before. One striking new finding is that Andromeda's mass could be significantly larger than that of the Milky Way, which would change how we understand both galaxies' scale and influence. The James Webb Telescope has also delivered highly detailed images and spectral data of Andromeda, revealing new star formation and the chemical composition of these stars. This data is critical for grasping the galaxy's evolution and the potential for conditions favorable to life. Moreover, the telescope has observed increased activity in Andromeda's active galactic nucleus, which affects the surrounding environment and will shape the galaxy's future structure. By studying gravitational effects on stars within Andromeda, scientists also gain valuable insights into the distribution of dark matter, a mysterious substance that influences the behavior and evolution of galaxies. Understanding dark matter remains one of the greatest challenges in astronomy, and these new observations are helping to shed light on its cosmic role. Through numerous studies, Andromeda has revealed remarkable traits that set it apart from many other galaxies. Its immense size, with an estimated diameter of about 220,000 light-years, makes it one of the largest galaxies in the local group, even surpassing the Milky Way. This vast scale contributes to its mass, which includes around 1 trillion stars. Far more than our own galaxy. The structure of Andromeda is also intriguing. Unlike a typical spiral galaxy, it features a prominent bulging center and a dense nucleus surrounded by rings of dust and gas. These conditions foster ongoing star formation, illustrating a dynamic galaxy shaped by continuous processes. One particularly interesting aspect of Andromeda is its nucleus, which shows a double peak emission pattern. This hints at the presence of a supermassive black hole, similar to but distinct from the one in the Milky Way. Studying this offers crucial clues about the nature and behavior of such massive black holes. Surrounding Andromeda is a halo of stellar debris that spans hundreds of thousands of light-years, composed of stars, planetary bodies, and globular clusters. This cosmic envelope tells a fascinating story about the galaxy's origins and evolution. Among these clusters, about 460 globular clusters provide insight into star formation during the galaxy's earliest stages, helping to illuminate how galaxies develop over time. Andromeda also stands out for its many satellite galaxies. Its halo contains over 20 smaller galaxies, some of which are undergoing tidal stripping, a process where Andromeda's gravity pulls stars and gas away from these smaller neighbors. This interaction illustrates the ongoing evolution and growth of galaxies through their mutual influence and collisions. Looking ahead, the future of the Andromeda galaxy is a source of great interest. Astronomers are particularly curious about its shape and trajectory. There is evidence suggesting Andromeda might be transitioning from a spiral galaxy into a ring galaxy due to past interactions and collisions with other galaxies. This potential transformation reflects its complex history of encounters in the cosmic neighborhood. Ultimately, Andromeda's fate is deeply connected to its eventual collision with the Milky Way, predicted to happen in roughly 4 billion years. This monumental event will reshape both galaxies, resulting in a new, merged elliptical galaxy. Although the collision will be destructive, it is a natural phase in galactic evolution. The vast distances involved mean that it will not be a direct crash, but rather a gradual merging. The interaction of gases and dust during this process will spark intense star formation, creating a spectacular cosmic display visible across the universe. This merger will also lead to the eventual collision of the two supermassive black holes at their centers, adding a layer of mystery and complexity to this grand cosmic event. These phenomena highlight the intricate and ongoing story of cosmic evolution that scientists continue to unravel.